All right, ladies and gentlemen, this is lesson 86 for chemistry. Basically, what we're going to do is look at the dissociation of water first. It comes second in the chapter, and then we'll look at pH and uh, hydrogen ion concentration. To me, it makes a little more sense to explain it this way. I don't know, maybe it won't to you, but to me, it lets you see why this happens. So hopefully this makes sense when we all get through it. But I wanted to take a quick look at the Chem Catalyst, which sort of ties into the last chapters, Chem Catalyst as well, last lessons, Chem Catalyst, and I'll go over that one too. It says pure water has an H plus concentration of 1 times 10 to the minus 7th molar and OH minus concentration of 1 times 10 to the minus 7th molar. What does this mean? Well, it means we don't have very much hydrogen or hydroxide ion in solution. So you can see this number over here, 1 times 10 to the minus 7. That is a very low concentration, but it is there nonetheless. Well, because this ion concentration is so low, it does not provide for very good conduction of electricity. So in the previous lesson, 86, there were a couple of substances it asked us to look at. If they were in solution, you had 0.1 molar HCl, you had 0.1 molar acetic acid, you had 0.1 molar NaCl, you had 0.1 molar sugar. The ones that dissociate well are going to be good conductors of electricity. So the NaCl, the salt solution, and the hydrochloric acid solution are going to be very good conductors. The other two, the sugar solution and the acetic acid solution, are not going to be very good conductors. Again, we saw last time acetic acid doesn't fully dissociate, and so it is not going to conduct electricity very well. Sugar, on the other hand, it doesn't dissociate into ions. It just dissolves and stays in those little particles of sugar that are invisible in the water. And then when we get to the check-in from 86, which substance do you expect will conduct electricity? All but the last one, methanol, is not going to conduct very well. Again, same reason, hydrocyanic dissociates very well. Magnesium hydroxide dissociates very well. So both of those are going to conduct electricity. So dissociation of water. Basically, if we look at water, it looks like this, HOH. If we look at water on a very, very microscopic scale, what we would see is that a very small amount would become H plus ion in solution, and a very small amount of that water would fall apart into OH minus ion. And so we can see that these numbers that I provided in the Chem Catalyst are very small. 1 times 10 to the minus 7 is super teeny tiny for both of them. And why it falls in equal proportions is because, you're not going to have H plus coming off more than the OH minus. Is going to fall off in equal amounts. Now, this little bracket symbol that we see here is just a way chemists use to signify that we're talking about concentration. And so there's also something that we call the KW, the dissociation constant for water. The dissociation constant for water is always 1 times 10 to the minus 14th. Where does that come from? Well, if we take 1 times 10 to the minus 7th and 1 times 10 to the minus 7th, we multiply those together. The two concentrations are always going to multiply out to get 1 times 10 to the minus 14th. Now, this is very important for when we look at acid chemistry, because we can predict, or we can find, the H plus ion concentration if we know pH, we know POH, we know OH minus concentration. We can find the other guys. And, if we're looking for the H plus, all I need is one of those other three. I can find what's going on with H plus. So let me get some more stuff on the board here, and we'll be back in just a second. All right. So to finish our talk on lesson 86, we need to take a look at something called pH. pH is associated with the hydrogen ion concentration, this H plus thing right here behind my head. So, anyway, what we need to think about here is that some of you are probably going to have a little bit harder time than others on this because of the math involved. If you don't know anything about logarithms, because you just haven't gotten to it in your math class or anything like that, you may find it a little bit harder. Those of you who have run across it in your math class, you may have a little easier time with it. But basically, what it has to do with is on your calculator here. I'm going to try and get it up. This button right here where it says log. Okay. For this particular type of calculator, what you want to do is you want to punch in whatever the concentration is. You punch it in scientific notation usually. Again, you have to go 1, if it was 1 times 10 to the minus 11th, you would go 1 and then hit this EE and then 11, 1, 1 here, 1, 1, and then you'd have to hit, because it's negative 11, you'd have to hit the little plus minus key. So this calculator is very similar to this calculator. You punch in the number first. But for this one, this type of calculator, if you have this type of calculator, basically what you have to do is you have to hit the log button over here. And then when you hit the log button, at that point, you're going to get a little parentheses. And then you're going to punch in the 1 EE minus 11. So let's see here. On this calculator, where is it's a second function. Oh, EE is right there, but you have to go second and then EE here. So anyway, I hope that helps you with the calculator. If you go to the appendix A17 in the back of the book, it's not a page number. It is appendix A17. So it's not like page 295 or something like that. Just go to the back of the book, find A17. It gives you a rundown on how to deal with the math of logarithms. If you're having trouble, you can always email me. I'll be happy to go through it. Well, the type of problem you're going to run into for this type of problem is, let's say you're given a solution of an acid with a pH of 3. Okay, so what would be the H plus hydrogen ion concentration, the OH minus hydroxide ion concentration, and the POH be for this particular type of acid? Well, I could literally change the number. I could make this POH of 3. You could do a number of things with this type of problem. I'm going to give you one example. Unfortunately, I can't give you thousands of examples because this would take forever, but I'm going to try and get through this one and then allow you guys, hey, email me questions, things like that, and hopefully you can get through what we're going to do. Most of the problems I've kept, if you look at the numbers that I've assigned, I've kept it pretty easy to deal with. I will tell you this, when it comes to a couple of the quiz questions and stuff like that, you might not get a dead on number of 3. You might have pH at 2.8 or something like that to deal with. If you have a pH at 2.8, it becomes a little bit harder to deal with. I'm going to show you how easy it is to deal with if it's just a pH of 3 here. But the idea is, all right, pH of 3 means that this H plus ion concentration is 1 times 10 to the 3 molar. Where did the 3 come from? It came from right there. It's always going to be in the pattern 1 times 10 to the minus some number, okay, for the most part, okay? And if we put minus 3 in here, it's going to be rare to see a pH of negative 3. And so just be thinking of that, be aware of that. So this minus 3 gives us positive 3 for a pH. Why does that happen? Again, it comes from the fact that pH deals with what we call a logarithmic function. And so basically what pH, it's negative the log of the hydrogen ion concentration. So if you were to punch into your calculator log of 1 times 10 to the minus 3, you would get minus 3. And then if you take that negative, you would get positive 3 that we started with in the problem. I know there's a lot of negatives and positives and blah, 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 blah going on here. Watch this a few times. Watch what's happening with it. Check out that appendix A17 in the back of the book. Hopefully this starts to make some sense. If it doesn't, email. All right. And then if we ever need to find the H plus, and so basically what I did is I did the anti-log of the negative pH. So what I had to do was take 3, plug it in here, call it a negative 3, and then to do the anti-log, what you do is it usually doesn't say anti-log on your calculator, but it's always the second function. So you go the second and then log, and then plug in that negative 3. If it's this type of calculator or this type of calculator, you plug in negative 3, second, and then log. And that will give you this 1 times 10 to the minus 3. Okay, hopefully that makes sense to there. And then if you remember from our first segment of this video, we said that the Kw is 1 times 10 to the minus 14th. That's always, again, the H plus concentration and the OH minus concentration multiplied together. So to find the OH minus, or the missing one here, I take 1 times 10 to the minus 14th, and I divide it by the other one, 1 times 10 to the minus 3, the one that is known. That would give me a concentration of 1 times 10 to the minus 11th molar for the OH minus concentration. Now, there's 2 ways that you can find the POH. I prefer the first one over here, but we could always do it this way, okay? The first way is to understand that pH plus POH will always equal 14. So since this one was 3, this one has to be 11 in order for that one to be 14, okay? So 3 plus 11 gives me 14. Always going to be what is the pH plus what is the POH is going to give me 14. The other way is to do it just like we did the hydrogen ion concentration. POH is going to be the negative log of the OH minus concentration, which we found here was 1 times 10 to the minus 11th. So negative log of 1 times 10 to the minus 11th. If you plug in log 1 times 10 to the minus 11th, you're going to get minus 11. Take the negative of that, you get 11. So again, there's a lot going on here math-wise if you don't have a whole lot of experience with logarithms. Hopefully you have some. If you have none, this may be a little bit tough. Try and find your calculator. Make sure you understand where that log button is. Play around with it. The back of the book has a couple of exercises. Try punching it in. See if you get the same. The answers are given in the book. So you should be able to, do a couple of them. See, did I get the right answer? If you did get the right answer, you're plugging into your calculator right. If you didn't get the right answer, you might want to send me an email. Hey, Wyatt, can you walk me through this pH, POH thing? It's kind of confusing me. So hopefully that helps with lesson 86. T-Wyrick at auhsd.net if you have any questions. Good luck on lesson 86 homework.